Okay, so rational functions and asymptotes. So vertical asymptote, remember all our vertical lines are in that form, x equals a. It says it's a vertical asymptote if of the graph of f when f of x approaches infinity or f of x approaches negative infinity as x approaches a. So some value. The horizontal, this is our horizontal line. It says that as f of x approaches b, some value as x approaches infinity or x approaches negative infinity. Okay, so those are a little wordy and a little hard to understand. They're a little easier when I show you the graph on the next page. All right, so we have this graph. And this graph has a vertical asymptote right there at x equals -1. So x equals -1 is my vertical asymptote. And if we look at the definition, it says the line x equals a, so x equals -1, is a vertical asymptote of the graph when f of x approaches infinity. So if you look at this graph, as I come from this side, I start going up towards infinity forever and never quite touch that line. That's what makes it a vertical asymptote. If I look from this side, I'm going down towards negative infinity. And that makes it a vertical asymptote. Now, you could approach it from positive infinity on both sides, but in this case, our vertical asymptote approaches opposite things. A horizontal asymptote, like this one, has a horizontal asymptote at x equals 2. What it says is that as x gets bigger and bigger and bigger, so x approaches infinity, this gets closer and closer to 2 without ever touching it. As x approaches negative infinity, this gets closer and closer to 2 without actually touching it, which is what makes it a horizontal asymptote. Vertical asymptotes are really easy to find. You're going to want to write this down because the horizontal asymptotes wouldn't fit on this page. So asymptotes of rational functions. If n of x, n standing for numerator, so if n of x over d of x, denominator, the vertical asymptotes occur at the zeros of d of x. So this is at the zeros of the denominator. The zeros of the denominator, remember, are what we call our excluded values. Or we also call them restrictions on the domain. So vertical asymptotes are really easy to find. I just look at the denominator and I look for my restricted values. And that's generally where the asymptotes are going to be. There is a special case, well, not a special case. There is a case where they're not, and we're going to talk about that in just a second. But generally speaking, so if I have a function f of x equals x over x plus 2, then if I want to find the vertical asymptote is where? Okay, what value? Yeah, so x equals -2 is my vertical asymptote. And if I plug that in on my graphing calculator, we can see there at -2, there is indeed that vertical asymptote. Those are the easy ones. I'll give you a second to write for this next one for horizontal asymptotes, and then we'll go through it. Yeah. Okay, I'll give you a second to write on this horizontal asymptote one. Okay. So we can have at most one horizontal asymptote. There's not going to be two, not going to be three. And it talks about comparing the degrees of the numerator, which I called this n, and the degrees of the denominator, which I called this d. And it says if n is less than d, so I'm just going to make up a function, f of x equals x over x cubed plus 7. The degree of the numerator is 1. The degree of the denominator is 3. 1 is less than 3. So the graph of f has a horizontal asymptote is at x equals 0. Always. I don't even have to do any math. The degree of the numerator is less than the degree of the denominator. It's always going to have that. Now, horizontal asymptotes are not like vertical asymptotes. Vertical asymptotes, the graph cannot cross. What horizontal asymptotes are talking about isn't so much the middle part, it's talking about what's going to happen at either end. So let's go ahead and graph this guy here. X divided by x cubed plus 7, did I say? Okay. Graph. Let me zoom in just a little bit there. So if we look at either end of the graph, it's getting closer and closer and closer to 0. But if we zoom in, we can actually see that the graph crosses over 0 and then comes back down to it. That's okay. Horizontal asymptotes, they're often going to cross, but what it's saying is that as x gets further and further and further out, it's going to get closer and closer to 0. And if we look at our table, you can see that as I get further and further and further out, I'm getting closer and closer and closer and closer to 0. Now, remember, this is all scientific notation. So this means 9.8 times 10 to the -4. So that'd be 0.00098. So as I get further and further, I'm getting closer and closer and closer to 0, but I'm never actually getting to 0. That's what a horizontal asymptote does. And if I go the other way, as I go further and further out, I keep getting closer and closer to 0, but I'll never actually get to 0. But in the middle, the graph can actually cross over. That's okay. One more. Okay. Oop, no, still too close. There we go. All right. So if n equals d, okay, let's just make up something 2x squared over 5x squared plus 1. So if the degree of the numerator, second degree, equals the degree of the denominator, also second degree. Whoa, what happened? Hi, there we go. Don't know why I did that. The degree of the numerator equals the degree of the denominator. Then the asymptote occurs at the ratio of the leading coefficients. So all I have to do is look at what's the leading coefficient of my numerator, which is what's the number in front of the highest power, that's 2. What's the leading coefficient of my denominator? That's 5. So I'm going to have a horizontal asymptote at 2/5. So at either end of the function, it's going to approach 2/5. And if we, what do I have? 2x squared divided by 5x squared plus 1. Little crazier graph kind of. Ooh. Let's see if we can get that glare. There we go. So if I go ahead and I'm going to draw the line of 2/5 in there, which is right there, that's that horizontal asymptote. We can see that the graph is approaching 2/5 on this side, and the graph is approaching 2/5 on that side. And if the numerator is greater than the denominator, so f of x equals 2x cubed minus 1 over x squared, where the degree of the numerator is greater than the degree of the denominator, there's no horizontal asymptote. So you have to know these 3 rules. If the numerator is less, it's x equals 0. If they're the same, it's the coefficients. If it's greater, there's none. There's 3 rules that you're going to have to memorize. Let's look at some examples. Find all asymptotes of f of x equals 3x squared plus 5. So I'm going to be looking for vertical asymptotes. I'm going to be looking for horizontal asymptotes. Let's start with horizontal, just because we just talked about it. What's the degree of the numerator? 1. What's the degree of the denominator? 2. 1's less than 2, so what asymptote does it have?
0.
Yeah, x equals 0. Done. All I had to recognize was that's a 1, that's a 2, so x equals 0. Now, vertical asymptotes occur where? Where do we say they occur? The what of the denominator? The restrictions or the zeros. So set the denominator equal to 0. Oh no, what kind of number is this? This is an imaginary. So vertical asymptotes, we would say there are no real vertical asymptotes. So it has a horizontal asymptote at x equals 0 and no real vertical asymptotes. Yes. Because the degree of the numerator is 1. The degree of the denominator is 2. So if the numerator is less than the denominator, it's always x equals 0. That was the first rule. It's always, it doesn't, you don't even have to do math. If this is 2 and this is 3, it's x equals 0. If this is 2 and this is 7, x equals 0. It doesn't matter. Now, when I do these, when I was learning this, I would always, after I figured it out, after I did the math part, I would always plug it in the graphing calculator because it didn't take me but a second to do. And when I plugged it in the graphing calculator, I could see the function. And this one's gonna, but this one's probably gonna be really, well, hold on a second, somebody has stat plot on. Okay. Oh, might help if I actually put it in the right. There we go. I'm like, what's happening? And we can see that it does look like it's getting closer to 0, but there isn't any vertical asymptote. There's no spot where it's going up on both things. All right, let's do this one. Vertical asymptotes occur where? Denominator. So this one I can see is a difference of 2 squares. So that's just x plus 4 and x minus 4. So where are my 2 vertical asymptotes? Well, that's -4 and that's +4. So in this one, I'm going to have 2 vertical asymptotes. Now for my horizontal asymptotes, what's the degree of the numerator? What's the degree of the denominator? 2. They're both 2. So they're the same. So the horizontal asymptote is the ratio of the leading coefficients. What's the leading coefficient in the numerator? What's the leading coefficient in the denominator? 1. 4 over 1 is 4. If I go ahead and graph this one, just to check, I get this kind of funky graph. And you can see that there appears to be something going on right here at -4. There's a vertical one. Something there at 4, that's a vertical one. And then at either end, it's approaching some value, which does look to be right at about 4. So I can be pretty happy with that one. Now, not every 0 of the denominator is a vertical asymptote. They can also be what's called a hole. And a hole means it's an excluded value, but the definition of a vertical asymptote says it has to approach infinity or approach negative infinity. These don't do that. And holes occur when I can simplify my rational function and eliminate one of the zeros. So in this one, I can factor this top. That's going to factor into x plus 1 times x plus 1. I could just written squared, but I'm not going to for a reason. And the bottom, if we factor it, factors into 6x minus 7, x plus 1. Now, this plus 1 here and this plus 1 here can cancel each other out. So at x equals -1, it's a hole. It's not a vertical asymptote, it's a hole. Literally, the function will go to that point, there will be an open circle, and then it'll go on. It cannot equal anything at that, but it's not a vertical asymptote. So I would still have a vertical asymptote, though, at this one. So 6x minus 7 equals 0. Add 7, divide by 6. I would still have a vertical asymptote at x equals 7, 6. What about a horizontal asymptote? Would I have a horizontal asymptote? What's the relationship of the degrees? What's the degree of the numerator? It's 2. What's the degree of the denominator? 2. So they're the same. So my horizontal asymptote is the ratio of the leading coefficients. Well, the leading coefficient of the top is 1. Leading coefficient of the bottom is 6. So I still have a vertical asymptote, a horizontal asymptote, but I also have a hole at -1. And then sometimes they want you to go ahead and find out what that value would be. It's a limiting process. What's it approaching? The easiest way to usually do that, though, is to go into your calculator. X squared plus 2x plus 1 divided by 6x squared minus x minus 7. There's my vertical asymptote, which at 7, 6, 1 and a sixth. My horizontal asymptote's fine, and my hole is at -1 comma something. If I go into my table, at -1, we see that it says error. But I can kind of zoom in on this. It looks like it's 0.0008, maybe something around that. So this would be like maybe 0.0008, just looking at the values on either side of it. If they ask you for the coordinate, sometimes they will also be okay with there is a hole at x equals -1. I'm usually happier with that, but sometimes they're like, what's the coordinate? So you're gonna have to go into the table and zoom in and see what it is. Okay, two more. Let's see if you can do this one. Find all three. What's the easy one to find? The horizontal. Because we know that the degrees are the same, so what's the horizontal asymptote? Y equals 3. It's a ratio of 3/1. Now, the vertical asymptote, we find that this doesn't factor, does it? Huh. Well, maybe it's some weird number. I'll try the quadratic formula. So negative b plus or minus b squared minus 4ac all over 2a. Negative 1 plus or minus 1 minus 12 is negative 11. So we find that the zeros are imaginary. So this has no real vertical asymptotes. And if you can't factor this, you can't cancel anything out. So there's also no holes. Thank you. So there's no vertical asymptotes. There's no holes. Is the function continuous? Continuous meaning it doesn't break anywhere. If there's no vertical asymptotes and no holes, then yes, it is continuous. So we have a horizontal asymptote at y equals 3. There's no vertical, no hole. It is continuous. All right. One other thing that you're going to see that's super easy, but if I didn't talk about it, you'd be like, what? So find all zeros of the rational function. Looks really, really difficult. Really, 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 really is not. Okay. So to find zeros, I just set it equal to 0. multiply both sides by 2x plus 1, and what happened? I lost my denominator. When you're looking for zeros of functions, we only care about the numerator. Because 0 divided by anything except 0 is 0. So we don't care about the denominator. The only thing that you have to make sure is that it's not an excluded value. So we know that x cannot equal negative 1/2 from our denominator. So as long as our zeros aren't this, we're totally good. All right, so I go ahead, I factor this out. Looks like -1 plus 1. And so I get x equals negative 1/3 and x equals 1. Those are my two zeros. They're not a restriction. So done. That's all it is. So you just need to worry about the numerator. Your assignment is on WebAssign.